and the xPON related models that were implemented in the VOLTHA. That is basically implementing the channel groups, channel pairs, and the channel termination and the partition, including the VONTNI, ONTNI, ENET, which you can see is defined into the blue color of this WT385. So these are the actual implementation, including the VENET, which is outside of the blue area. And as of now, we don't have the link table implemented. So you can see the VENET and the actual ENET and the VONT A9 A9 and the channel termination to the port link, and these are they are missing. There are stories for that, but they are missing. So for now, we will use the same name as both of the interfaces have the same name. So they are basically tied by their actual names. So which I will show you in the scripts when I run the demo. And this is compliant to the WT385. And the first, as you can see, the OLT chassis and ONT chassis, they are not having any parent or child relation, which is something VOLTHA has to complete in the future eventually. Okay. So also you can see from the architecture slides, the CLI REST, they go through the global handler to the local handler, then to the xPON handler, and to the config handler, which is actual database. And from the database listener, it's xPON agent that passes over to the adapter agents and then goes to the individual device adapters. So as of now, the HA requires all the requests to be handled by the global handler from the northbound before giving it to the actual local handler. So for now, we are still under the implementation of the global handler for the xPON related stuff. So the scripts are using to go directly towards the local handler, which will change in another week or so. Then we will adjust the scripts to use directly the global handler and let the HA takes care about the actual instances. So I will explain that in the demo as well. So as far as this concern, this is the topology. I'll show the topology in my scripts as well. So the topology is the channel group. There is one channel group called Manhattan, and the partition is WTC, and the channel pair and the channel termination, they are named as a PON port as per the PON SIM module that is that is publishing the port name as a PON port. And so in absence of the link table, we have to use the both as a PON port. And then is the actual VONT ANI, which is AT&T Golden User, and the ONT ANI, which is again AT&T Golden User, and the ENET is VNet is ENET UNI. So I'll start now. So first I will start the PON SIM. And now I'll start the actual VOLTHA. So the VOLTHA is up and running. So in the same time, now I will go and issue the commands. And while I issue the commands, I'll explain them what are those. This is to communicate with this is to provision the PON SIM OLT and allow communication with the PON SIM itself, which is PON SIM device. And on the CLI, we can make sure that it's really communicated. Okay, so the PON SIM is active and it's been connected, and also PON SIM by default it creates say one ONT. If I don't specify number of ONTs, so this is the ONT that it created. So this is the thing we will not change for now, but we eventually expect the adapters should not create their own ONTs. They should be created by the xPON model itself. So the next part is about creating a channel group and the channel partition. I'll do both in the same. This is the first one is the channel group, and the second is for the channel partition. Okay. So this created the channel group and the channel partition. As you can see, there is no communication from the xPON edge, means xPON model of the VOLTHA to the PON SIM device itself, because we haven't completed the rest of the script where we attach the ports. So the next one is about channel pair. So this is adding a channel pair inside the channel groups. So linking the channel pair and the channel partition as well. So this creates the channel pair. Now the next step is about channel termination. This channel termination is the actual port that physically exists on the OLT, and the channel group, channel partition, and the channel pair is actually a fiber plant which is in the field. Okay, so the channel termination to the channel pair is actual link between the actual fiber plant to the OLT device. So this is going to link the OLT device to the fiber plant. So at this time, as soon as I execute this, the PON SIM PON SIM device should receive everything about the xPON, because it knows, it is aware, xPON is aware about that particular device where the channel termination is. So as you see this, you can see now all the data has been received by the PON SIM. Okay, starting from channel group, channel partition, pair, and then the termination. Okay, so which is associated to this particular device. It depends upon like which device the channel termination is. It will be communicating only to that particular device. And then the next is about the creating an ONT user, which is AT&T Golden user, and the next one is ONT ANI and the VONT ANI together. I'll create both of them. Okay, as I create them, they are being dispatched to the actual PON SIM device. You can see there AT&T Golden user for the VONT ANI and the ONT ANI config as well. Okay, so the next step is creating the actual ENET port on from the configuring actual VENet port on the OLT device. So this is also been dispatched to the PON SIM in over here, which is here ENET. So now PON SIM is aware about all the devices, all the information about the xPON data. On the CLI as well, at this time you can see now, previously you see there was only one ONT which was created by the adapters. Now you can see the actual ONT which I provision over in my script is called PSMO001 is the serial number. So you can see this serial number now being populated as a PSMO. Okay, if I go to this particular device, you can see the actual serial number of the ONT that is being populated by the xPON. Also, same time, if I go to the xPON submodule and then do the show, All it will show is the channel group, channel partition, pair, termination, ONT, and the init. Everything is displayed. Okay. So the next step in the next demo I will show you is the deleting these interfaces. So as they get deleted, they will be removed from the device, and it will be communicated to the PON-SIM device for their to delete them as well. So first I will delete the VENet only. Now it will see the remove interface for the VENet from the PON-SIM. At the same time, on the CLI, if we just go to the CLI and do the show one more time, now there is no more init. Init is empty. Okay. Previously, this was the init over there. So same thing I will repeat for the next two, which is the A9, VNT A9 and the A9. And then I will show the next step about the channel termination. So this also gets reported to the PON-SIM to remove them from the device, as well as from here you can see now there is no ONT ANI and the VONT ANI. So as well there were three devices, two of them by default this ONT was populated by PON-SIM, and the third one was the PSM 001, which has been deleted now as a consequences of deleting the VONT ANI and ONT ANI from the xPON. Okay. And now the next step, I will disconnect the fiber plant from the channel termination. So to do that, I'll just delete the channel termination from the xPON. Okay. As soon as I delete this, there is a link between the channel termination and the pair is been broken, means it's been removed, the references. So as soon as that happens, the fiber plant is disconnected from the actual OLT. So it requires the xPON to inform the OLT device, which is in my case is a PON-SIM device, to inform it to delete everything from the channel termination, pair, partition, and the group in one single step as a consequences of a single step. Okay. So I'll just delete this, and you can see now more things have been terminated. It says like remove the channel group and remove the channel partition as well, and then they remove the channel pair, and then it's in the removing the channel termination as well. It goes into the stack order. First the channel termination, then pair, then the pair, partition, and then the group at the end. Okay, so that removes everything from the device. So now we can see here there is no change on the devices because we didn't delete the device yet. But on the xPON, we still have the channel group, partition, and the pair, but no termination. Now, because we didn't delete the actual configuration of the group and the partition and the pair, by executing these three steps, we will deleting them from the VOLTHA. But to demonstrate, as soon as we disconnect the channel termination from the fiber plant, the device should be updated. That's what I want to demonstrate by deleting the channel termination in the last step. So now I will delete the whole configuration of the channel group and everything. Okay. There will not be any communication at this time to the PON-SIM device because device is no longer part of any of the group provisioning. It's only for the VOLTHA itself. So there's nothing is left for the groups. So as well, I will go and delete the PON-SIM OLT itself. You can see there is nothing. Okay, so we are back to the normal at this time. So same way, we have the CLI script as well. which will do exactly same thing as as the curl script does. So as soon as we complete the global handler work for the HA, then we will be replacing this local objects that we mentioned here for the path as local will be removed. So then it will directly talk to the global handler. That will happen in 1 week or so. Okay. So I can demonstrate to you the CLI as well. Okay. I need this device maybe to be copied. Okay. So now I will go and enable the device just like I did last time through the curl script. And this time we'll be using the now you can see the PON SIM is again connected, the PON SIM device, and the PON SIM device has populated one of the ONTs. Okay, so there is a communication going on with PON SIM. So I will go ahead and provision the channel groups and the remaining part up to the channel partition and the channel pair, except the channel termination. So you can see what really happened there. So this is only up to the pair, and there is no communication with the actual PON SIM device. So we go ahead and attach the channel termination to the pair, which is connecting the ONT to the fiber plant. So as this happens, the PON device has been PON SIM device been updated for all the information related to the xPON, starting from group to the channel termination. So group, channel partition, pair, and the termination. In the next step, I'll provision the ONT, which is the PSM001 ONT, and it's associated ONT NI and VONT NI for that particular ONT. So as this happens, again the xPON will inform the PON SIM device about the VONT NI and the ONT NI. Okay. And the next step is about provisioning the ENET. So that informs the ENET as well is being created on the PON SIM device. Okay. So going back to the show command here, you can see everything is available. And previously there were only 2 devices, now it should be 3. The third one being the ONT device as a consequence of the ONT and ONT NI provisioning. You'll see the same ONT is being populated here. Okay.
Can you show the ports here, just out of curiosity? Oh.
Okay.
Okay, thank you.
At some point, just a little injection, right? So the device ID, all those IDs, I think for operation, that's a long series of a character we need to look at, right? So I don't know. I mean, for the operational feasibility, is it, maybe we need to think about how to present it easier for people to understand. But that is just a question. So go forward with complete your demo first. I think you're in the middle of something. Sorry, I asked the question.
No problem. These device IDs are auto-generated by the core right now. They represent the first 4-letter represents actual instance, and then the remaining is the actual device, which is all random generated numbers.
Mm-hmm.
Sometime back, Srisha has been asking that we want this to be a part of a pre-provisioning, just like what you said. But there might be story on that one as well to the core, because it's not only limiting to the ONE, but it's also for the OLT provisioning itself. So this is the OLT provisioning that also covers the same. So there's
Anyway,
something that.
To answer that, sorry, go ahead. Do you have something else? No, I was just trying to say that if either Ken or Sergio are on the call, which I don't right now, they probably would be able to better answer that, because this was a decision taken a long time back to randomly generate the device ID, which is a 12-bit UUID, they use the 12-bit UUID generator to generate that. It's not preferable to do that, especially when we are looking at NetConf configuration or even other things. I think there are certain cases in OpenFlow that needs the device ID to be known well ahead in time as well. So there is going to be an enhancement later to make it more deterministic as opposed to using a random generator. So they're going to actually have an internal number which is random for the core, versus there's going to be something that's externally visible that will be more deterministic. That's what I heard, but I'm not sure where the story is right now, and when it's going to be up in Sergio and they're available.
Yeah, because right now, I think that's something, it is what it is, but later on, yeah, those can be too complicated for operation to follow if they ever want to use the CLI, right? So
right, not just CLI. I mean, with NetConf, it is totally impossible because you can't do pre-provisioning if you are expecting something back from the core to provide you, right? So it is.
Yeah, I remember that. Yeah.
Yeah, it's already the designers are aware of that, and they wanted a story. I'm not sure, to be honest, if there's a story or not. But yeah, let's discuss with them again.
Right. Okay. I think Niran, you still have some demo need to do. Finish.
Yes. Yeah, the last part. So now, as we completed the create, I will go and delete them as well. So the first, I will delete the init. And that should show the PON sim has been deleted for the init as well. So as you can see here, the remove interface and the init has been deleted from the PON sim. So for the remaining, I'll pick the next two, which is the ONT ANIs and the ONT ANI. Okay, and the same being deleted from the PON sim. Okay, been informed to the PON sim device as well. And now this time I will disconnect the same channel termination from the fiber plant. So that got disconnected, and so the PON device been informed to terminate, to remove everything from the channel termination to channel termination, channel pair, channel partition, and the channel group as well. So this is just because the device is no longer part of any of that particular channel group. So on the CLI side, you can still see the configuration still exists in the VOLTHA, but it's not required on the device. Okay. So then go and delete the remaining 3 as well. So that cleans up the xPON And now I can go ahead and delete the device itself, which is the OLT device. And now you can see that there is no device left over, and everything is back to as it started. And this stories, this particular script has been already part of the VOLTHA 151 and VOLTHA 152, and we'll update over there as we make the global handler progress as well in the change of the script.
So just to give you a little bit of more detail on what is in progress right now. So what Nirain just demonstrated has been updated in sprint 1, and sprint 2 we just did not pick up any big stories. We just tried to clean up certain items, mainly because of the capacity and vacations. And in sprint 3, what we are doing right now is that Nirain has shown all this configuration being pushed to the OLT. So there's some configuration that needs to be pushed to the ONU adapters as well when this is set in the VOLTHA core. So that's being done right now. So that way, whenever there's configuration, it gets propagated to both the OLT and the ONU adapters, the respective ONU adapters, and then they'll be able to communicate with the core. So those stories are in progress right now, and once that's complete, there are other stories as well in the backlog that we plan to look at, which is the highest priority, and pick it up. And the one more thing that we have in progress right now, which is the whole global handler thing that Nirain has been talking about. There are a lot of fiber plant related items which are common to several OLTs and not device specific, and therefore they need to be available to all the VOLTHA instances in the case of HA when there are multiple instances. So that's something that is in progress right now. So when you look at the device ID or the identifier, there's a 4-bit identifier, which is a VOLTHA instance identifier, and then there's a 12-bit identifier, which is actually that random number. So that's being done for channel terminations. It's already actually done. We're trying to push that in right now. So it'll be very similar to how the device configuration goes in. But for the rest of them, which are not specific to a device, they would be using the VOLTHA instance ID and like a deterministic global ID, which is common, which means that it goes to all the instances. The VOLTHA instance ID for all instances broadcast is FFFF, or it's F. So that's pretty much what is in progress right now. And there's like also iTest. Everything that Nirain demonstrated here is also implemented as a part of integration test. So it will help us to quickly check if the code is still sane for VOLTHA. I mean, if we were to run the iTest, we would see the same problem with PONSIM in case if it didn't come up. So I think that's pretty much it for this sprint. And then next sprint will probably pick up stories like TCON and templates.
You can also do from the Swagger as well. As you can see, the Swagger has now plenty of commands for the channel route, channel partition, pairs, termination, UNT, A9, ENET. So everything is possible from the Swagger as well. Just like as it comes.
Let's research. So on that ONU configuration, right? So that should be adapter independent, right? No dependency on which type of adapter it is.
Yes. If you have the PONSIM adapter output, can you please bring that up a little bit, Nirain? I just want to show those interfaces real quick. Say, for example, here you see PONSIM remote interface. That will be the exact same interface that's called towards the ONU adapter as well. Only the interfaces that are relevant to the ONU will be sent towards that device. And the interfaces are all common. It's just the data is also based on the protobuf message. So if for an ONU, it only needs ONT ANI, only that configuration is sent. It needs INET information, only that configuration will be sent. For example, the channel group, channel partition, channel termination, channel pair information will not get sent to the ONU adapter. All that logic is on the core.
Okay.
The interfaces are generic. Like it doesn't. In fact, we try to make them generic so that it doesn't. They're not even PON specific. They're just called create interface, because if you were to create a different kind of interface, it could be the XDSL or something. You could still use the same API, but the protobuf that you're using, the message, the data structure that you're using is going to be.
On the ONT, it will be the UONT-NI, ONT-NI, and the VENet. And in the future, it will be TCONT and the GEM as well.
Okay, good. Okay, and I'm sure. So far, all your testing, at least also on the ONU side, also just against the PONSEM, or you actually test your code against the real ONU right now? Sirisha?
I'm sorry, can you repeat that, Sean?
I mean, so right now, all the development right now is all on the PONSEM and the OpenU OLT simulator right now. There's no real device has been tested so far.
No, no Kia devices have been tested.
Okay. I think that's it. Maybe we can stop the recording and save it.
Okay, I'll try to save it and not lose it. So, okay. Thank you, everyone, for joining, and thanks, Nirain.
Thank you. No problem.
Okay, thank you.